In this video, we are going to take a simple part from concept to reality using the SC-512L. For our first project, we are keeping things simple and making a brass pawn. This Fusion file is available to download from the link in the description. You can design and model your own part, or you can download an existing model from the internet. For this example, I downloaded the pawn and imported it into Fusion 360. Once the model is inside Fusion 360, we can move over to the Manufacture tab. The Manufacture workspace is where we will create the toolpaths that tell the CNC lathe how to machine the part. The first thing we need to do is create a setup. The setup tells Fusion 360 the size of our starting material, where the part is located inside that material, and how the machine axes are oriented. In the Operation Type dropdown, ensure you select the option labeled Turning or Mill Turn. This tells Fusion we are making a program for a lathe. For this pawn, we are starting with 1-inch diameter brass stock. For the stock length, the exact dimension is not very important. It simply needs to extend beyond the entire model. We also want a small amount of extra stock in front of the model. This gives us material to remove with our facing operation and makes sure the finished front of the part is completely cleaned up. So we will change the model position to offset from front, then change the offset to 0.02 inches. Next, we need to verify our orientation. The Z-axis should run along the length of the stock. From this view, we also want the X-axis pointing down. Once our stock and orientation look correct, we can press OK to create the setup. Our first toolpath will be a turning face operation. Facing removes material from the very front of the stock and gives us a clean surface to start the rest of the part from. For the cutting tool, we are using our generic tool library available for download using the link in the description. We will select tool number 6. Tool number 6 has a sharper approach angle, which gives us good access around some of the tighter features on this pawn. Next, under Feed and Speed, open the Preset dropdown and select Brass. The presets in our generic tool library are intended to provide a good starting point. You can adjust them depending on your tooling, material, and application. For this operation, we are going to disable constant surface speed and set the spindle speed to 3000. We will leave the feed mode set to feed per revolution and use a cutting feed of 0.02 of an inch per revolution. That is all we need for this operation, so we can press OK. Fusion 360 will now generate the facing toolpath. Now we can begin removing the majority of the material. From the turning operations, select Turning Profile Roughing. Profile roughing removes the bulk of the stock while intentionally leaving a small amount of material behind for our finishing operations. For roughing, we are going to select tool number 5. This is a neutral angle tool that works well for reaching most of the geometry on this part. Under Feed and Speed, select the Brass preset. Once again, disable constant surface speed and set the spindle to 3000. For our cutting feed, we will use 0.06 of an inch per revolution. Next, move to the Passes tab. Set the maximum depth of cut to 0.40 of an inch. We will also leave 0.20 of an inch of stock in both X and Z. That extra material gives our finishing tools something consistent to remove on the final passes. Press OK to generate the roughing operation. Looking at the toolpath, you can now see that most of the original 1-inch stock is removed, while a small amount of material remains around the finished profile. Now we need to remove the remaining material and create the finished shape of the pawn. We are going to use 2 finishing operations because of the different angles and features on the part. For the first finishing operation, right-click our original face operation. Go to Create Derived Operation, select Turning, and then choose Turning Profile Finishing. Creating a derived operation carries over the tool and several of the settings from the original operation, which saves us from entering everything again. This operation will use tool number 6. The sharper angle of tool number 6 allows us to reach and finish the upper portion of the pawn. Since we only need this tool to machine the head of the pawn, we are going to limit how far back this operation can travel. Go to the Geometry tab. Under the Back section, set the back mode to Model Front. With no offset, this would place the boundary directly at the front of the model, so we will enter an offset of -0.433 inches. This moves the boundary back far enough to include the entire head of the pawn while preventing this tool from continuing down the rest of the profile. Once that is set, press OK to generate the finishing operation. Now we need a second finishing operation for the remaining profile. Select Turning Profile Finishing. This time, choose tool number 5. Under Feed and Speed, select the brass preset, disable Constant Surface Speed, and set the spindle speed to 3,000 revolutions per minute. Our finishing feed will be 0.02 of an inch per revolution. Press OK. We can now see that the two finishing operations work together to complete the pawn profile. There may be a few very small areas where the tool geometry prevents us from perfectly following the model. For an aesthetic part like this pawn, those small areas are not important and will not affect the finished result. The last machining operation is parting. This operation cuts the finished pawn away from the remaining bar stock. From the turning operations, select Turning Part. For our parting tool, select tool number 3. Under Feed and Speed, select the brass preset and disable Constant Surface Speed. For the initial portion of the cut, set the spindle speed to 2,000. Set the feed to 0.02 of an inch per revolution. Next, move to the Passes tab and enable Use Reduced Feed and Speed. Set the reduced feed radius to 0.197 inches. For the reduced feed, enter 1,000th of an inch per revolution. Set the reduced spindle speed to 500. This slows the part down as we approach the center of the stock and the pawn becomes separated. Since the finished part will no longer be held once the cut is complete, slowing the spindle helps keep it from being thrown around the enclosure at high speed. Once those settings are entered, press OK. Our machining operations are now complete. Now we need to convert these Fusion 360 toolpaths into G-code that the machine can run. We will do that by creating an NC program. You can post the toolpaths directly in other ways, but using an NC program makes it easy to save the configuration and post the same program again later. Inside the NC program, select the SineCore Post Processor. If you have not installed the Post Processor yet, there is a link to our installation video in the description below. For the program name, we will enter Brass Pawn. Next, choose an output folder where the finished G-code will be easy to find. Set the output units to match the profile you are going to use on the machine. If you are running the inches profile, select inches. If you are running the metric profile, select millimeters. For lathe mode, make sure the automatic tool changer is selected. Now open the Operations tab. Checking the box next to our setup automatically selects all of the toolpaths underneath it. Any operation that is not checked will not be included in the final program. Once everything we want is selected, press Post. At the bottom of the window, Fusion 360 will confirm that the program was successfully posted. The G-code is now ready to move to the machine. If this computer is connected directly to the machine, you can access the file from there. Otherwise, you can transfer it using a USB drive, your network, or whatever method works best for your setup. Now we are at the computer connected to the machine. With the program transferred to this computer, press the Load button on the left side of the screen. Select our Brass Pawn program. Once loaded, the program G-code will appear at the bottom of the screen and the toolpath should appear in the visualizer. Before running anything, make sure the machine is homed and that ATC mode is enabled. Next, install the brass stock in the chuck. At this point, we are assuming the tools have already been set using the tool probe. If you have not set up your tools yet, follow our tool probe setup videos before continuing. With the tools already calibrated, all we need to establish now is the Z-work offset for our stock. Jog one of the cutting tools close to the front face of the material. Bring the tool to the stock face and set the Z-work offset. This tells the machine exactly where the front of our programmed part begins. With the machine homed, the tools calibrated, the stock secured, and the work offset set, we are ready to run the program. Press Cycle Start, and we can watch the pawn go from a model inside Fusion 360 to a finished part on the SC-512L. If you found this video helpful, consider subscribing for more setup guides, machining tips, and tutorials. If you have any questions or run into anything unexpected, send us an email at support@sinecorecnc.com and we'll be happy to help. You can also check the description for helpful links, related videos, and additional setup resources. Thanks for watching, and we'll see you in the next one.